Hi, everyone, and welcome to the FogLAMP architecture and demo presentation. So here's the FogLAMP architecture. FogLAMP has a plugin-based architecture. There are over 150 plugins that you can use to construct the exact data flows that you want at the edge. FogLAMP South plugins are used to connect and collect data from your various data sources. Some of the South plugins that we support already are Modbus, OPC UA, and Ethernet IP. There are also other South plugins that connect directly to sensors. Data is then sent to our storage service where it's buffered in the case of intermittent connectivity. And then data is sent through the North service using North plugin to your end destination. Some of the North plugins that we have are the OMF plugin that can send to Aviva Pi server or Aviva Data Hub, the GCP plugin to send data to Google Cloud Platform, and other plugins exist as well to connect up to other clouds and other platforms. Filter plugins are used to transform data in flight. Filter plugins could be as simple as, say, scaling values, or they can carry out more complex tasks, like running ML inference at the edge. Filter plugins could be attached to pipelines as data is coming in through the south before they go into storage, or as data is going northbound through North services. An event service also exists so that you can create alarms out at the edge. An event instance is composed of two components, a rule, which determines if an event has occurred. Some of the rule plugins that we support is things like threshold rules that determine, is the temperature greater than, say, 30? Or some of the other rules that we support are ML based to use ML inference to determine if an event has occurred. The actions then are just that, what action to take if an event has been detected. Some of the actions that you can use, action plugins you can use out of the box are things like creating another asset that goes into the storage so it could be sent northbound. Another action to take could be to send an email or a text or a Teams message if you want as well. A set point control service does exactly that. It facilitates the messages and actions needed to carry out set point control. And FogLAMP has a REST API that could be used to configure the FogLAMP. In fact, our FogLAMP GUI uses this exact REST API, and you can use the REST API to connect to your systems as well. All in all of these FogLAMP plugins, of which we have over 150 no-code plugins out of the box, can be used to construct any type of workload that you want at the edge. If a plugin doesn't exist to do what you want, the API for creating new plugins is documented and published. So you can create a plugin if you want to yourself. You can have us create one, or even have a systems integrator create one if you want to. Now that we've talked about the architecture, I'll dive into the first demonstration that I wanted to show you. On your manufacturing floor, you must have multiple different assets that carry out your tasks. Some of those assets may be a hydration tank, a centrifuge, or a pump. In this case, on that same manufacturing floor, these assets may be connected to different PLCs, and each of the PLCs may support a different protocol. Like this PLC supports Ethernet IP, this one Modbus, and this one OPC UA. Using a single FogLAMP, you can connect to all three PLCs because FogLAMP supports multiple SOUT plugins, including the Ethernet IP PLC plugin, the Modbus plugin, and the OPC UA plugin. You can connect and ingest data from all three of them in parallel. Moreover, using filters, we can do things like rename some of the assets if they're inappropriately named, or you can add metadata to those readings so that when they end up at their end destination, that metadata is also held and can be used. Now, in our case, and possibly in yours, you could have a situation where you can't send from FogLAMP directly to a cloud service or to the end destination because of security requirements. In this case, we solved that problem by sending data from FogLAMP at the edge to FogLAMP within the DMZ serving as a relay. And the FogLAMP serving as a relay then sends data to, in this case, the Aviva Data Hub and the Aviva Pi server. So let's jump into the actual FogLAMP instance and take a look. This is the fog lamp that serves to connect to the three PLCs. We're looking at the FogLAMP GUI right now, which is pretty reflective of the FogLAMP architecture. You can see here that south of FogLAMP are the three connections that we have to the PLCs, one to the Ethernet IP-based PLC using the Ethernet IP plugin, a Modbus-based PLC using Modbus plugin, OPC-UA PLC using the OPC-UA plugin. You can see here that if I jump into the configuration of one of those connections, things are configurable like the address to connect to the port and so forth. Whether to use TCP or RTU, the register map that you want to get data from. And you can also see the filter pipeline, the applications to transform and enhance that data in flight connected to the south side in this case. Here we're adding this metadata hint to say that when data arrives in Pi, we want it to go into this specific asset framework hierarchy. Now, on the on the assets and readings side, I can take a look at the readings in flight, and I'll do so just by doing a simple trend. The last 10 minutes of the Modbus data coming in. You can do that within the FogLAMP GUI itself. And now on the north side, we can see the data being sent out. Again, instead of sending directly to the Pi server in Aviva Data Hub, we're actually using that relay, right? Because we're at the edge and we can't go directly to the cloud. On the second fog lamp, serving as the relay within the DMZ, I'm still receiving all of that data from my fog lamp running out at the edge using this south side connection to the fog lamp at the edge. And on the north side of this fog lamp, I'm sending to my two destinations, one to the Aviva Data Hub and one to the Aviva Pi server. The north plugin that I'm using to send data to these destinations is the OMF plugin. And since both of these endpoints support the OMF protocol, I could use one plugin to send to both. Now, in the case of sending to the Aviva Pi server, that asset framework hint that I used and that I enhanced the data with allows me to send to the Pi server in exactly the way that I want to. You can see that the data lands in the Pi server, my northbound integration, using the exact hint that I specified. And so all of the data could be enhanced using these asset framework hints so that they are then landed in Pi in the exact way that you want. I'll now jump into the second portion of our demo, one in which we're not connecting to PLCs, but in this case, we're using FogLAMP to directly connect to three sensors. In your factory floor, you may have a motor or industrial asset that you want to do a few things to. You want to monitor it for indications of early failure or wear for condition-based monitoring purposes. And you want to monitor the environment that that asset's in this case, for safety purposes. You might have a camera out there that is meant to see if somebody's getting close to that motor because, that particular motor nobody can get close to. So in this case, we use FogLAMP to connect up all of these sensors to, for the purpose of solving both of those use cases. The FogLAMP is connected to the IR camera using our GennyCam South plugin, the Spinnaker South plugin connected up to a FLIR camera. If I go to that FogLAMP, I could see the readings from that particular infrared camera. And in fact, let me show you on my USB camera that exact setup that I have in my lab. So that is the motor that has an accelerometer mounted on top of it, an IR camera, and the USB camera all pointed at the motor. The image that you're seeing here is the IR image that FogLAMP is saving the FogLAMP GUI is able to display that image. I'm going to turn on the motor so that you can see it. You may hear it now too. There's a low frequency buzz perhaps going on. And you can see that bearing that the camera is pointed at warming up here. Now, this part of the data flow to collect from the IR camera has no filters. And the reason why is because we're simply collecting that data because we want to then send that data to the Google Cloud Platform for the purposes of training an ML model. And once that model is trained, we're going to push it back into the FogLAMP then to be run. So I do that by looking at the north flow and looking at this GCP connection that I have using the GCP Python plugin. I see that I'm using a filter to only send the infrared camera data to that destination. So even though I have all of these workloads happening in parallel, in this case, I'm only sending the infrared camera data to GCP. Now, the next thing that I have pointed at this camera is my safety camera. My safety camera is a USB camera that's using the Video for Linux South plugin. It also has a filter that's running an ML model that's already been built to detect if somebody's near the camera or near the motor. If I look at that asset, and just to show you, this is the data flow, safety camera here attached, a filter to detect, an ML filter that detects the number of people in the frame going into FogLAMP. And if I look at that particular reading, you can see that these are the readings, the image readings that are coming into FogLAMP from this USB camera. This is our IR camera pointed at the motor, and the USB camera is looking at it. And on the bottom are the inference results of the ML model overlaid on top of the image. Now, if I put my hand in the frame, you'll see that the person count increases. And that's because the ML model has recognized that there's a person in the frame. In this case, because I'm waving my hand very quickly, it was seen as multiple people. But that's really just the opportunity to further tune the model. These model inference results help to create alarms and so forth as well. Now, our last data flow is the accelerometer connected on top of the motor. That accelerometer is collecting at 8,000 hertz on a continuous basis. Using the Digiducer plugin, we're collecting high frequency raw vibration data. I'm sorry, here. High frequency vibration data in through FogLAMP. That raw vibration data then goes through a series of filters. One is an ML model that detects if a bad bearing or a good bearing is running. The second and third are signal processing filters, root mean square analysis, and fast Fourier transform to get summary values from that raw vibration data. These are typical vibration signal processing techniques that are done. And going back to our data flow, even though we're collecting a lot of heavy data into this FogLAMP and doing a lot of processing, sending out through the FogLAMP to our Pi server are just the summary RMS, FFT, and inference results that we're sending, not even the raw vibration data that's continuously being collected. So if I look at the OMF North instance here connected to the Pi server, you can see that I have a filter to only send the RMS, FFT, and bearing health status. And again, I'm attaching a asset framework hint so that when data gets to Pi, it's placed in the exact hierarchy that I would like it to be in. Okay. Now, lastly, our third demo shows you a glimpse into FogLAMP Manage. The FogLAMP suite is composed of fog lamps that run out at the edge and carry particular workloads, and FogLAMP Manage, which is used to monitor and configure these fog lamps at scale. What we're looking at now is the GUI of FogLAMP Manage. The Fog Lamps tab shows you all of the fog lamps that we've added into this that are under management of the FogLAMP Manage. You can see the health status of all of these fog lamps and their individual services. You can see how much data they're ingressing and egressing. This value is updated every 15 seconds, so you may see it change. And we're also able to group these fog lamps using groups of a feature of FogLAMP Manage that allows you to, group entities in the way that you want. Right now, I added the edge group and the DMZ group because that's how I wanted to organize them. Fog lamps at the edge and fog lamps within the DMZ. I also added the label of location so that I can label my fog lamps. This one's in the cloud. These two are on site in Fresno. Now from here, I'll go into the flows page. FogLAMP Manage is used to model and create the data flows that each of the fog lamps run. Here I've added the assets that I have in my factory floor. I've added the data sources that make data available for those assets, whether it be the PLCs or the accelerometer and directly connected sensors. You can see the different filters that each of these data flows undertakes. Here's the bad bearing ML filter and RMS and FFT. Here's the person detection one for the safety camera. And you can see which fog lamp these data flows are connected to. And finally, what integrations these fog lamps are sending to as well, and the filters attached on the north side for that purpose. I could look at the particular configuration of a single entity. If you remember, we had the Ethernet IP PLC configured in a particular way, and here's the centralized view of that configuration. 192.168.036 is the IP of the PLC. The tags to read from, the asset framework filter that we added here as well. Going back to the flows page, you can also sort by either the assets, the data sources, by FogLAMP, or by integrations. And you can see here that I'm looking at a single integration, the Pi server, which is connected to all three fog lamps. Although, the one from the PLC directly, the fog lamp is disabled, but the other two are enabled. Now, a feature of FogLAMP Manage is that I have one integration connected to all three PLCs, which means that if I change the IP of that PLC, of that integration of that Pi server, or I change some credentials, or I want to change some property of its connection, I can make the change in FogLAMP Manage to this entity and deploy this change to all the fog lamps that it's connected to if I want it to go that way. So make a change in one place, have it reflect to everything that's connected to it, if you configure it to do so. A version control, I'm sorry, I'll jump into the templates. All of the data flows that you see modeled here were the result of using templates to build those data flows. Templates is a feature that allows you to cookie cutter configuration so you could rapidly deploy them and scale with ease. So in the case of the integration template that we use the OMF template to set up the connection to a Viva Data Hub and the Pi server. Same thing with the GCP template to set up the Google Cloud Platform connection. And we can build templates, we can refine templates, again, all in the spirit of cookie cuttering configurations that can be replicated and deployed to multiple fog lamps at scale. FogLAMP Manage also has a version control system, which allows you to dig down into the history of FogLAMP version deployments. So this is a version control system. You can see who made what change to which FogLAMP at at what time. You can look at the current view of FogLAMPs and the FogLAMP data flows, or you can visit the past and say if I select on an older version and I go to the flows page, I'll see the view of FogLAMP of the FogLAMP deployments at that time. You can see here that I don't have my relay added yet either, and I don't have my connection to the Viva Data Hub. And that was what happened in version 1.0.5. But right now we're in 1.0.10. Finally, FogLAMP Manage has, oh, and I'm sorry, the version control system also has the ability to do rollback so that you can roll back to previous versions if you want to as well. Finally, FogLAMP has a user management system in which you can add new users and give them particular roles. Ones that we support right now are administrator, editor, and viewer, if you wanted to have a view-only user. So I thank you again for joining our demo. Thank you.